So first, let us discuss heat engines. So heat engines are any device that transforms heat partly into work or mechanical energy. So ito actually yung reverse nung nakita natin na block that is slowing down due to friction tapos producing heat doon sa ating table. So heat engines are devices that are trying to reverse yung direction na yon ng thermodynamic process. So we will start with heat, tapos we will convert this heat into mechanical energy. So some definitions that we need to know. First, we need to define what is a working substance. So the working substance is the one that is undergoing the thermodynamic process sa ating heat engine. This is also what you will call yung substance that is undergoing the thermodynamic process sa refrigerator later. So for the simplest heat engine, the working substance undergoes a cyclic process. So this is good to note. So now let's look at how this cyclic process happens inside a heat engine. So let's look at one cycle sa ating engine. Tignan natin ano yung ina-undergo ng engine in one thermodynamic cycle. So again, for simplest heat engines, cyclic yung ating process, which is shown dito sa ating pressure volume diagram. Okay, so let's go through this. First, what happens is that your intake valve here will open up, tapos papasok ngayon yung ating working substance. So this working substance here is a combination of fuel and air. So yan yung magiging working substance ng ating heat engine. So currently sa ating PV diagram, nandito yung ating state. So what happens next is yung ating working substance. As your intake valve closes, yung ating working substance is being compressed by this piston. Okay. So it will undergo this path here. So that process, yung compression na ito, that is an adiabatic compression, meaning no heat is introduced sa ating working substance. So after that, when it reaches yung highest point, this is the lowest volume ng ating working substance, yung ating spark plug will now ignite. Tapos mag-start yung combustion ng ating working substance. So with that combustion, heat is introduced doon sa ating system as shown sa ating PV diagram here. That is our Q sub H that enters our working substance. Okay, so the volume is maintained pero nag-increase yung pressure doon sa ating working substance because heat was introduced. Afterwards, our working substance begin to expand, no? As that pressure goes down. So ganun yung magiging process. So that expansion, again, balik natin. That expansion is still adiabatic, no heat is introduced during this expansion. So as it increases yung volume, bumaba yung kanyang pressure. That's that path here. Next, what will happen is this valve here, which we call the exhaust valve, that will open up as yung piston natin will go up. So with that, mag-exit yung ating working substance palabas. So in that process, through the expel of this exhaust gas, yung na-burn na fuel, lalabas din yung heat, QC. So ito yung heat na lalabas. Tapos, this repeats yung process. Mag-open ulit yung valve and babalik tayo sa starting point natin. So cyclic siya, although as we've seen dito sa process, nag-change talaga yung ating working substance. No? Hindi ito yung same working substance that we had before. Although pag refill nung mixture ng fuel and air, bumalik tayo sa ating original na state. So the total work done in one cycle nung ating working substance is defined nung area nung ating PV diagram. So this is the area. So we've seen what happened here is we've introduced heat through the combustion nung ating working substance. Tapos nag-expel din tayo ng heat through pag-expel ng exhaust gases nung na-burn na fuel. So meron tayong QC. Tapos the total work done by our heat engine in one cycle is the area inside. So this diagram here is what we call an energy flow diagram. This diagram shows yung pag-flow ng energy through our heat engine. So actually, we can see here what we've seen doon sa cyclic process sa ating PV diagram. So we've seen, so this circle here represents yung ating engine. We've seen kanina that heat is introduced doon sa ating working substance through the combustion of our fuel and air mixture. But we've also seen that it has expelled some heat through the exhaust, and then yung area inside our cyclic process kanina sa PV diagram, that is the work done by our heat engine. So we can see here yung pag-flow ng energy. So energy enters our working substance, energy exits our working substance through the exhaust gas, and then work is done by the engine doon sa ating piston. So let us define some terms here. Itong area dito, this is what we call the hot reservoir. So this is the heat source for our working substance. Now, ideally, we assume this as a source that can provide large amounts of heat without changing its temperature. So this is not the case in reality. Mauubos mo talaga yung heat that is from our fuel. But for our analysis, we will assume that this is an infinite source of heat na provide papunta sa ating engine. Another thing we need to define here is the cold reservoir. And this is a body that can absorb large amounts of heat at constant lower temperature. So for the case of our heat engine, so yung cold reservoir mo is the outside ng heat engine. So that could be the environment outside the car kasi doon din papunta yung exhaust gases mo. And yung heat that comes from your exhaust gases, doon din siya papunta. So we don't expect the environment to increase or change its temperature as we release exhaust gases by a large amount. So from what we've mentioned before, a simple heat engine will follow a cyclic process para sa ating working substance. So let's apply the first law of thermodynamics for cyclic processes. So we know that for cyclic processes, the change in the internal energy ng working substance natin should be zero. And from the first law of thermodynamics, our delta U should be equal to Q minus W. Now, from our energy flow diagram, we can see na may dalawa tayong heat. The first one is Q sub H, which is the heat entering yung ating engine. And we have Q sub C, which is the heat exiting or expelled by your engine. So our Q here will be composed of those two heat, Q sub H and Q sub C. So from this equation here, we can write our heat is equal to the work done by our working substance. So like we said, ang ating heat flow, Q, is the sum of both heat, Q sub H and Q sub C. Now recall yung sign convention that we have shown before. If heat is entering our system, so positive dapat yung kanyang value. And if heat is expelled from our system, so that will take a negative value. So actually, we can express this equation that we have here in terms of the absolute value ng ating Q sub H and Q sub C. So take note, our Q sub H is equal to the absolute value of Q sub H. So this is true because we know that the value of Q sub H should be positive. On the other hand, our Q sub C will take a value of negative times the magnitude of Q sub C. Kasi alam natin that Q sub C should take a negative value. So let's plug these values here doon sa ating total heat. So Q is equal to absolute value of Q sub H minus the absolute value of Q sub C. Now that we know yung value ng Q, we can show that this is equal to the work done. No? So equal siya sa work done. Okay, so let's talk about this equation here. What it tells us is that yung heat na na-introduce sa ating engine ibabawas mo doon yung heat that is expelled sa exhaust, and you will get yung amount of work that is done by our engine. Now, ideally, we want this value here to be 0, but in reality, meron talagang energy loss always in the operation of heat engine. So we can move these terms around. So we can see here that from the heat that we have introduced dun sa ating engine, some of it goes dun sa work done. So yun yung magiging work done ng ating heat engine. At sa sasakyan, that will go to the rotational motion ng tires. No? And that will push our tires forward. That will push our car forward. So yun yung nagpapaandar ng sasakyan. But some of it goes dito sa ating Q sub C. So this is actually what we call the energy loss. Kasi gusto sana natin to convert heat to work done, pero hindi lahat ng heat na nilagay natin naging work done. Some of it was lost, hindi natin nagamit for work, and was expelled. So this is the reality that we can see na kung gusto natin i-reverse yung preferred direction ng thermodynamic process, hindi natin siya magagawa perfectly. Meron talagang energy loss when we try to reverse yung natural direction ng process. As we've noted before, ang natural direction ng process is work done converted to heat. Kung gusto natin i-reverse yon, we will always experience this energy loss. And only a portion of the heat that we introduce is converted to work done. But depending on how an engine converts, kung gaano siya kagaling mag-convert ng heat to work done, we can define its thermal efficiency. So thermal efficiency is simply the fraction of work that is done given yung amount of heat that we have introduced doon sa system. Now, since we've said that the work done, this work done here, is equal to this difference here, so pwede natin siya ilagay doon, that we can get another equation for thermal efficiency. Or we can write that as 1 minus the absolute value of Q sub C over the absolute value of Q sub H. So these are some ways of calculating yung thermal efficiency ng given engine. Now for the common engine na meron tayo sa mga sasakyan natin, the efficiency is usually equal to 20%. Which means 80% ng energy galing sa gasolina natin is exhausted out of the car. So merong energies doon na hindi natin nagagamit to move our car. Now, one of the most efficient engines that we have today are Formula 1 engines, so the race cars. Currently, their efficiency is at 52%. So, malaki pa ring energy ng fuel that is lost sa exhaust. And the only reason bakit umabot sila ng 52% is they're trying to convert yung heat na napunta doon sa exhaust gases into energy. So, meron silang MGUH that is converting heat to electrical energy. Tapos, they're also converting yung brake power from mechanical energy na pag-brake. Yung produced na energy, they're converting it to electrical energy. So, hindi lang ito sa combustion engine, itong 52%. So, this is a combination of electric recovery systems and yung combustion engine. Pero, 52% lang yung naabot natin. So, you see here yung downside that is produced by the second law of thermodynamics. And this is reality. This is reality. If you want to reverse yung preferred direction of thermodynamic processes, you have to pay this cost. No? So you can't do it with 100% efficiency. So that is the heat engine.